Hey everybody, thanks for joining us on this Wednesday workshop. Today we are talking about utilizing a
byproduct from
byproduct.
cheese production for de-icing. If you're interested or you're looking for something alternative, this may be your answer. So we are happy to have Joe Herod with us today from Leprino Foods Company. He came to the Snow and Ice Conference in Loveland last year and is going to tell us a little bit more about this approach. So without further ado, Joe, I will send it over to you.
Okay, let me see. Let me share the screen. Let's see. All right, can you see that? Of course, I'm on my presentation, so I can't see your thumbs up. Let me get.
Yep,
let me,
we sure can.
We sure can.
All right.
Yes, we can see it.
All right, so here I want to talk to you all about using cheese brine for well, there's lots of different uses, but potential uses. But for us, we're talking about using spent brine for de-icing purposes. We're going to go through this, and this has been a long journey, and I'll share with you some of the details of some of the things that we've experienced. And if you have any questions, I'll probably make sure you send them my email, and I can answer any questions they have later on. So the background about Leprino Food. So we're the world's largest mozzarella cheese producer, and we have 9 U.S. manufacturing sites. 10th, we just started construction. We did breaking ground in Lubbock this month. We have 2 sites in Colorado, and just as a background there, those 2 sites support 90% of the dairy production in the state of Colorado. We use a brine solution to cool the cheese during manufacturing. So mozzarella is a pasta filata, so you mix it up. It looks like taffy almost, and you have to cool it before you can further process it. And they use a 20 to 23% brine solution to cool it before they process it to certain shapes or shreds. You have to cool it down. But periodically, because of food safety concerns or microbiological growth, you have to replace or replenish the brine on a certain frequency. And just to give you in context, this brine that we use in our we call them our brine flumes or brine belts. We generate over 200,000 gallons of spent brine in Colorado right now for just those 2 sites. The only way you can really get rid of brine, well, there's a couple different ways, but in wastewater, isn't removed in biological wastewater treatment, which is what everyone uses to be able to clean up their wastewater. So it's essentially blended with other streams, and we have to use so much water in the cleaning of the site itself that we have pretty large volumes of wastewater on a daily basis. So you would blend it in, and the salt at a certain level to keep it in acceptable ranges for the environment. Now, we try to conserve water at Leprino, and whenever we do, salt concentrations or TDS is increased, and that's not a good thing because freshwater environments where you discharge this material, you can't have too much salt in there because it impacts the aquatic organisms. So I came to Leprino in 2012, and in 2013 I started. I'd learned about what they're doing in Wisconsin. Wisconsin had been doing it for 3 or 4 years, utilizing mozzarella brine in their road applications, and I wanted to do the same thing. So it took a long time to get to where we're at today. So there really wasn't a lot of interest, and I've got plants in 4 or 5 states across the country. So we kept looking and talking to as many people as we can, and really didn't get a whole lot of interest until CDOT came into the picture, because I'd actually talked to some individuals at CDOT about this material, but I didn't get many takers. But CDOT started a program where were looking at investigating the use of ag byproducts for de-icing purposes, and they started using, I'm not sure, because they used mag chloride for years, but they started using sodium chloride, and they started importing that. I believe it comes in from Utah, but they started importing it from out of state and making up their own brine solution to do like a release agent on the roads. They contracted and brought in Montana State because they've got a cold climate operations group. Laura Fay is the lady there, and she's fantastic. She's she's definitely a de-icing expert, and they were working with her, and I think, she connected with us and she said, hey, you guys have any streams or what are you looking at? And somehow or another, our paths crossed, and that was a good thing because they took our brine that we had and they took it into their laboratory, which people use for, for their determination of the material of, how good it actually is to compared to other products. And they said, hey, you know what? Your brine works better than virgin sodium chloride or brine. And why does that take place? And she's the technical expert, but I'm gonna use her words or things that she's explained to me. But the organic material in the brine itself inhibits the ice crystal formation. That's a big deal. And there's other metals in there too, other than sodium. There's calcium and magnesium, and that's this next bullet where the corrosion rates are less than virgin brine, and it helps. And with the organic material itself, it actually has a lower corrosion rate than the virgin material that they bring in and mix up themselves. Now, Leprino brine has a lot of phosphorus in it. We'll talk about that because that's a big deal. It is now anyway. It wasn't when we first started, but it is now. And phosphorus is present in milk, and it actually leaches into the brine. So, phosphorus is a nutrient, and everybody's concerned with nitrogen and phosphorus in water and things in the environment because you don't want to have algae blooms and impacts of that. So there's a concern there, but again, let's talk about what we did and why. So what happened next after?
Hey, Joe.
Yes, ma'am.
I only see your front
slide.
It didn't move.
It hasn't
forwarded. No.
Okay, I'm indexing through it.
Yeah, I heard you say next.
I heard you say next bullet.
Oh, now it goes. Now it's advanced.
Now it's advanced.
All right, so that was the background.
Yep.
This was what I just talked about as far as the phosphorus. Then how about now?
Yep.
Did it change again?
Yep. Perfect.
Next steps to conduct the CDOT
trial.
Okay, sorry about that.
Nope, that's fine.
So
that's fine.
You don't want to start over, do you?
No, I think we can keep going.
Okay, so the spent mozzarella brine can be used in two different ways for de-icing. So particulate pre-wetting, where you're wetting either the sand or the salt granules, or direct spray. Now, to let you know what was going on in Wisconsin, they were using it for particulate pre-wetting. So what's the beneficial use permit from CDPHE is actually needed to be able to do this in the state of Colorado. So CDPHE's regulation tells you that if you're going to use something for beneficial use, it's got to meet the spec of any related product. So that's a big deal because CDOT, they changed their spec for brine, and I think it was around 2018. It might have been a little earlier, might have been a little later, but they used Western States spec for years, and it had a total phosphorus limit of 2,500 milligrams per liter. But they changed their internal spec, and it changed it down to 25 milligrams per liter. And that's a big deal because our total phosphorus in our brine is 150 plus, depending on the day, the different products it's used on. So, and to tell you, the mozzarella brine in Wisconsin is the same. It's the same brine, has high levels of phosphorus, but since they use it for particulate pre-wetting, is very little used, so they consider it de minimis, and they didn't consider the phosphorus content and didn't require them to do any treatment outside of just removing the fat. They had to run it through a UF to remove the fat. So that's where we wanted to start with, because to be able to treat it, we know how to treat it. You just have to use metal salts to take the rest of the phosphorus out, and so to get down below 25 milligrams per liter. So we decided, how do we want to use it? Let's use it as is in particulate wetting, just like they do in Wisconsin. And then if we're gonna ever do any direct spray, we're gonna have to figure out a full-scale way to do this thing to treat this, because we have in excess of 200,000 gallons of storage right now just waiting to be used for CDOT, because we knew that we were trying to get this test in place. So it's a lot quicker, costs less money, and to use it as particulate wetting, but it doesn't use it up nearly as fast. We really would like to use the direct spray because it would definitely make sure that we got rid of all our inventory every year. But again, we got to set up the treatment system to be able to take the phosphorus down to below that 25 milligrams per liter. Next slide. So was the next step to conduct this trial. So we applied and we received a trial beneficial use permit for the 2022-2023 season. So we got it right at the end of this year, which is not a whole lot of good, but they did come and pick some up and try it and test it out, and everything looked really good. So as soon as we get to this next winter, they're going to get really interested, and I'm sure they're going to show up for it. Now, the permit that we applied for only applies to particulate wetting because it was de minimis amounts for total phosphorus. The calculations very, very low in terms of how much phosphorus hits the ground. CDOT also had to go through and, they did a lot of work on this with Laura Fayette at Montana State, had all the technical information. CDOT had to show the test sections roads they're going to use, how they were going to apply it, and then, had to stay away from water bodies if at all possible, so they could turn it on and off to make sure that we didn't get any runoff that would make it into any of the water bodies. Well, so this really is a win-win proposition for all, and it's very interesting to see how we can be smarter, and a lot of the ideas for this is, the Colorado's watershed, the net salt exposures decrease because we've already got our salt and they're importing salt from out of state. But if they can use our salt and displace some that they're bringing in, it's actually a net decrease for the whole watershed. CDOT can get free brine. It was, some of the CDOT folks were interested in, I think they wanted to know what we were going to charge them. We said, you guys don't understand. We're going to give it to you for free. If you want to come get it, get it. That's how they're doing it in Wisconsin. They actually just put poly tanks out in the front of the site. They fill them up, and whoever gets there the quickest gets to use them. And sometimes there's a fight between the state and the county folks, which they make sure that they use it all up because there's 2 or 3 things that they saw. It reduces their cost, but the other thing that they weren't counting on was the depressed freeze point, which was made the roads even safer, and that was a big deal for them. Now, also think about if I had to pay to get rid of my brine, I'm going to have to spend some money, so it helps me reduce our costs because we can't always. Sometimes I have to haul it off to someone else to stabilize it or put it into another larger wastewater treatment plant if I don't have capacity at the time, so it costs me money there. And then think about the greenhouse gas reductions associated with less salt shipped into the state. So we've also got a positive on the transportation side. Now we can also further our water conservation efforts by removing the brine stream. So that means that I can use less and less water, and I'm not going to continue to have this high brine concentration that will impact freshwater streams. The characteristics of the mozzarella brine, like I said before, actually allows a lower freeze temperature. It lowers it because of that organic content and some of those other salts that are in that material. And the corrosion rates definitely less than virgin brine. And when you do introduce, if I'm discharging my brine from my wastewater treatment plant, it's a point source. It goes into a stream. But if we put it on the roads and if there is any runoff, soil that interacts with the soil capture, and it actually will decrease the amount that gets into the water body. So there's the chemistry associated with the soil surface will keep a lot of those salts from ever making it into the stream, which is a really cool thing. So there's no downside. It's all upside for both parties. One of the biggest things I wanted to make sure I said that, there are going to be watch outs. And one of them is that brine needs to be in that 23% range. It needs to be really close to that because that's the ultimate melt point or the freeze point for the brine. So if it's more dilute or more concentrate, there's less freeze protection. Now, the way that they make up the brine today in the saturators, that would be the easiest way to do it is to take our brine if it was less than, because we sometimes add water to clean it and push the brine around. So let's say the material gets down to 18%. Well, you take that 18% brine, and instead of running fresh water through the concentrators, just run this brine and it'll take it up to saturation rates. And so there's a way to get around that. And I believe they tested that to make sure that there's no precipitate formed because that was a concern, but we did not see that. You got to get approval from the local health departments or environmental departments from each county. We had to get those approvals. So there's other people that got to get involved, but they were very supportive of this again because they knew that it was going to be a cost savings for their folks. To use for direct spray, you're going to have to spend money to add metal salts to precipitate out the phosphorus. phosphorus it's in the form of phosphate, so you can react it with metal salts, ferric chloride, PAC, alum, and it'll actually precipitate out. And then you have to filter it to remove those particulates or let them settle. There could be a reaction that forms a precipitate if mixed with virgin brine. That's what Wisconsin warned us, but they said it didn't always happen. I'm not sure if they know exactly which materials cause precipitate, but in the preliminary test that they did at CDOT, they did not see any precipitate forming in those 300-gallon particulate tanks. Because they said that you need to watch out was if you mix virgin brine with our cheese brine, there could be some material that forms out, but CDOT did not see that. And then brine, brine's got a lot of water in it, so you can't haul water for very long distances. It doesn't make a lot of sense. You got to use it as local as you can. That's why they bring in the salt from Utah, and then they add water to concentrate it up. That's a much better economic option if it's long distances. But if you got it, it's nearby, use it, keep it local. So those are the watch outs. Here's just some pictures. I was going to have any questions, but here's some pictures. This is, I don't know if you can see my cursor, but this is where we're storing the material in this, and they transfer it over, and they were doing it in these side saddle tanks. And this is what they pump out. So when they drop the particulates, y'all all know this, it drops down through the chute in the back, and then they spray the material. So it does two things. It keeps the material on the road so it doesn't bounce too far, and it sticks. But even if it's salt crystals or mag chloride or sand, it keeps it from bouncing and coming off the road and wasting your material. But it also actually adds some more freeze protection. So these are the trucks. This, even though this has a spray thing on the back, they actually just sent this big one because they said they don't want to keep sending these trucks over with these saddle tanks. They wanted to have some storage nearby so they could fill up, more closer to them, and there was no problem for us on that one. Let's see. And then this was the first application. When we finally got approval, we got a snow, they put it down, and they were showing us what it looked like, and everything worked as planned. So we're keeping our fingers crossed that as soon as we have our first big snow or freeze, that CDOT's going to come and they want to use up as much of this material as possible. And even after this one event, they've already asked if they could expand the roads that they try this on. And CDPHE is going to make us go through this approval process every time. It's not very fast, and they've been good to work with, but it's they had a lot of people look at this, and so it's definitely not as quick as I wanted it to be. But again, everybody's trying to make it work and make it a positive for us, CDOT, and the environment. So we're trying to do the right thing here. I believe that's it.
Okay, thanks so much for coming and talking to us again. What's the best way to get hold of you if they are interested in this?
Well, shoot me an email because JHERRUD, jherrod at LeprinoFoods.com, and that's the best way for them to get in touch with me. You get so many bogus calls nowadays on your phone. So if you send me an email and have any questions, start there, and I'll be more than happy to follow up.
Okay, sounds good. And as always, you can always reach out to us at Colorado LTAP, and we can put you in touch as well. All right, Joe, thanks so much for your time today, and hope to talk to you soon.
All right, take care. Bye-bye.